Hello, Math 113. There is a problem in section 6.2 that I want to help you out with. This might be your question 23. Keep in mind, your numbers might be different, but the method is going to work. So we have two ships that leave a harbor at the same time. One travels on a bearing of south 14 degrees west at 17 miles per hour. And the other ship travels on a bearing of north 75 degrees east at 12 miles per hour. How far apart will the ships be after 2 hours? So what we want to do first is attempt to draw a picture for this. So I want to draw a harbor, a dot, right in the middle of the page. I'm going to move over here just a little bit so I have a little bit of working room. Okay, so there's my harbor. You can call it H if you want to. And since I'm drawing bearing, y'all, every time I do bearing, I really like to draw a tiny little compass right on top of where I'm working. So we know this is north, and then south, and east, and west. And what's going to happen is we're going to end up redrawing this picture without the compass on top of it, but it sure helps a lot when I draw our bearing to have the compass there. So we have one ship traveling on a bearing south 14 degrees west. So remember how to do that. You must go south first, so south, and then 14 degrees in the westward direction. So this is really not going to be to scale at all, but this is the 14 degree angle right there. Really 14 degrees is much smaller than that, but that's about the best I could do. So that's ship one. Remember that ship is moving at 17 miles per hour. Okay, and then we have a ship 2. Let's do that in green. Okay, so our ship 2 is traveling north this time, 75 degrees east at 12 miles per hour. So when you do north, go north first, and then the 75 degrees comes off of north. So again, not to scale, but you know, this would be your 75 degrees. Okay, so when he gives you bearing, you go north or south first, and then you measure off of that north or south line the degrees that they give you. And this is going to be at 12 miles per hour. Okay, now notice that I made the green one longer than the blue one. If I were really truly doing this to scale, it would be shorter. So I'm going to back it back up just a little bit. Again, this doesn't have to be to scale. I don't want to give you that impression, but that would make more sense. Okay, now if they do this for how many hours? For 2 hours. So we're doing this for 2 hours. How far apart will they be? Okay, and so we have this line, this distance from 2 hours later, and we're trying to find out how long that line is. So the first thing I like to do is draw this triangle outside of the compass so you can really see what's going on. Again, it's not going to be perfect, but it's going to help us think about what we're doing here. So I'm moving it up just a little bit, trying to draw something similar. That one's shorter, and then this is what we're trying to find, right? Okay, now if we're going 17 miles per hour for 2 hours, remember the formula distance equals rate times time. So if we're going rate of 17 miles per hour for 2 hours, turns out the hours cancel and we're just left with 17 times 2 is 34. So that means that this line is a length of 34 miles. Okay, so that's the first ship. The second ship, which I drew in green right here, we're going 12 miles per hour for 2 hours. Okay, so again, 12. If you really think about that, it's miles per hour for 2 hours. The hours cancel and you get 24 miles. All right, that's 24 miles. Well, what about that angle in between? So I'm trying to calculate this angle that we have going on right there. Because remember, to use law of sines or law of cosines, you need 3 bits of information. It could be 2 angles and a side, or 2 sides and an angle. You can even do side, side, side. But we have angle information going on here. Well, let's go in with some crazy color, because I've used red and green and blue. Let's do this odd purple here. Okay, so I know that part of that angle, so this is the angle I'm trying to find, is 14 degrees for sure. And then you have this 90 degree angle right here, so that's 90 degrees. And then another part of that angle, how could we calculate that? Now remember, if we're 75 degrees off of north, and that's 90 degrees in the first quadrant, well, 90 minus 75 is 15 degrees. So that angle in there is the 14 degrees at the bottom, the 90 degrees in the middle, and the 15 degrees at the top, and that total is going to give us 119 degrees. So this is 119 degrees. Now it also helps in these pictures a great deal to have stuff labeled. Okay, so what I mean by stuff, your sides and your angles. So let's call this angle A. And we don't know angle A. And let's call this one angle B. We don't know angle B either, but we do know angle C is 119 degrees. Remember, the side directly across from angle A would be called side A. The side directly across, which is 34 miles, would be side B. And in this particular situation, we're looking for side C. And C is the distance between the first ship, which is this point down here, to the second ship after 2 hours, which really is the distance from A to B. Now, if we list what we have side B, angle C, and side A, which is definitely a law of cosines problem. Remember, you know you're dealing with law of cosines whenever your letters don't match. So if you don't have side A along with angle A, or side B along with angle B, that sort of thing, you must use law of cosines. Now, which law of cosines formula do I use? Well, the one involving C, because I have 119 degrees. So that formula, remember, is C squared is equal to A squared plus B squared minus 2AB times the cosine of C. So again, I'm looking for C. All right, so I'm going to end up taking the square root in a minute, and I have A, B, and angle C. So I'm just going to plug right in. C squared is equal to A squared, which is 24. I'm going to leave off the miles, but it would be 24 miles squared, plus B squared, which is 34, minus 2 times A, which is 24, times B, which is 34, times the cosine of 119 degrees. Now, when you type this in your calculator, as long as you're not looking for angle C, you're just, and that would happen when you're doing a side problem, but when you're looking for side, okay, and everything is filled in to the right, you're just, be careful typing in your calculator. It's pretty straightforward. But when you're solving for your angle C, that's when you have to be especially careful typing in your calculator. I can't speak clearly. Okay, so here I go. I'm doing 24 squared in my calculator, plus 34 squared, just straight in my calculator, minus. Now, you do not have to put parentheses around this multiplied part, but sometimes it makes me feel better, but I've tried it both ways, and you do get the same answer. So minus 2 times 24 times 34 times the cosine of 119, and close out parentheses around the 119 that popped up after cosine. Now, I say you don't need parentheses around this, but that's what the calculator I'm using. If you by chance get something different, typing that directly in your calculator that I get, try parentheses around that multiplied part. Now, when I type that in, I get, stand by, 2,523.2093. Now, y'all, I'm just going to leave that in my calculator. I'm only writing it down for you to have a visual. I'm not rounding it whatsoever, and that's why I suggest leaving it in your calculator. Okay, but just to check your work is the reason I'm writing that down. Now I'm going to leave that number in my calculator and take the square root of it. And that's going to give me my C value. So I'm going to hit second square root, second answer. And again, that works in my calculator, maybe not yours. And I get 50.23155,682. But we are allowed to round to the tenths place. So 50.2, remember that is miles. So when I answer this question, I would type in 50.2 right there in the box. They put miles out beside it for us. I hope that helps, and let me know if you're having any issues about this problem or any other. Have a great day.